asymptotic notations. Now, so based on our, understanding, this time, let us do formal definition of asymptotic notation. The first one, big O notation. Now, another notation, big O. Yeah. We have the little o notation, but this time big O notation. All right. Here, I give you the formal definition. For a given function g of n, the notation big O, we know it's a set, right? Yeah. From our understanding of the previous slide, it's a set. The big O of g of n, a set of functions, represent, here, I said that, okay? The set of functions f of n that satisfy the following condition. There exists some positive constant c and some non-negative integer n0 such that this inequality f of n less than or equal to c times g of n holds for all n greater or equal to n0. So this is the complete definition of that big O notation. Yeah. All right. So from this formal definition, so here you can see, to understand it well, so we need to, really spend some time here. Okay. Yeah. Here you can see this little n, the n0, that's new. Okay, that's new. Yeah, we didn't use this little n0 before. In our limit way, we never use the notation of this little n0. Okay, yeah. And here, why you, in your formal definition, you introduce some new notation here. Yeah. Actually, this little n0, its role is important here. It makes our understanding harder, but it's necessary. So we need it. Yeah. Here, let me spend some time to explain the role of this little n0. Okay. Yeah. All right. Yeah. So its role like this. Yeah. All right. Okay. So after you select it, so you have some freedom to select this number, okay, n0. So what is this n0? Yeah. You have freedom to choose n0. Okay. Yeah. But after you select it, it must be fixed. This constant, it's a constant. This constant must be fixed where n grows. Yeah. Because you can change the n value, right? Yeah. Fixed when n increases. Okay. When you increase your n values, this n0 has no change. Okay? Yeah. All right. And usually people use another way to represent this n greater or equal to some special n0 constant value. People say in this way, where n is sufficiently large. Another description for this n0 related condition, n is sufficiently large. In this expression, n0 does not appear. N0 does not appear. It's hidden. Yeah. So when you see this expression where n sufficiently large, you do not see n0 notation. Yeah. But it's hidden. N0 notation hidden. It means, yeah, there is some constant n0 where n greater or equal to that hidden constant n0, this inequality holds. Okay, sufficiently large. Yeah, because people may argue this sufficiently large, the wording is vague, right? Is the wording vague? Yeah, people can argue. So this wording is very vague. And sufficiently, when you use this word, it's not objective, right? Yeah, it's subjective. It's not objective. Okay, because for different people, sufficiently large has different meanings, right? For different people, sufficiently large has different meanings. Yeah, actually, not for different people, actually for different situations, the sufficiently large has different meanings. Yeah, has different meanings. So later we will see the different meanings. The sufficiently large. Yeah. All right. So here, that's the understanding. Yeah. If I use the visual representation for this inequality, so you can see the graph like this. So this is the graph. Okay, graph. From this graph, you can see, yeah, we have the graph of C times G of function. Okay, yeah. We use as an upper bound for f of n, the curve of f of n. So this one. Okay, but that upper bound relationship only works when n greater or equal to 0. So when n is at the right hand side of the vertical line for n0. So this vertical line represents n equal to n0. At the right hand side, that means n greater than n0. Okay? Yeah. And how about the left-hand side? It doesn't matter. So look at left-hand side, this way, right? Yeah. Which one larger? It does not matter. It does not matter. Okay? Yeah. For this capital big O notation, the behavior for the left-hand side of this vertical line is not important. Why is that? Yeah. So here, we just raise the question. So why it is not important? Yeah. Here, let me delay a little bit. Yeah. Let me delay a little bit. Yeah, because if I explain the reason why it is not important, I need at least 10 minutes. Okay, so I couldn't complete my PowerPoint slides today. All right, but I will spend those 10 something minutes later to explain why it is not important. Okay, I just delay it. All right, but the concept is important. Yeah, I have to explain that why it is not important. Otherwise, you cannot get a good understanding of asymptotic notations. Okay, all right. Let's go to some other asymptotic notations, but this time we just use the similar way as our previous formal definition. but the change mainly is at the inequality way. All right. The definition for a given function f of n, the notation big omega of g of n represents the set of functions f of n that satisfy the following condition. Yeah. There exists some positive constant c and some non-negative integer and 0 such that only lower bound function representation f of n greater or equal to c times g of n function, big omega, okay, lower bound estimate for all n greater or equal to n0. So here you can see the wording pretty much the same as the previous one. The only change is at the here inequality side. Yeah. If you look at the graph, so you have the graph like this, but this time you do the lower bound estimate. You don't care about the upper bound estimate. Okay, you just describe the lower bound estimate. Okay, still this side doesn't matter. Okay, for the same reason. Yeah, later I just explain this reason once. Okay, once for all. Yeah, for all asymptotic notations. Yeah, so we explain this part why just once. Okay, yeah, because they have the same reason. Yeah. All right. Another one, big theta notation. Yeah. Here we just change the inequality one. Yeah. The remaining, the wording pretty much the same as before. Yeah. Standard. Yeah. All right. Yeah. We go, oh, sorry. Yeah. I realized I got something not quite right. Yeah, sorry. Yeah. Yeah, I should know this. Something. Yeah, because this big O notation. Oh, okay. Yeah, that's fine. Yeah. So this big O notation, upper bound. Okay, good. Yeah. One side estimate. Yeah, from upper bound estimate. All right. Yeah. Then big omega notation, lower bound estimate. That's fine. Okay. Not wrong. Yeah, not wrong. But this big theta, both sides, quite natural, both sides, we can estimate function f of n from both upper bound and the lower bound. Okay, yeah. We see this kind of thing, we saw it before, all right? This time, if we use the graph visual way to represent it, we have both upper bound and the lower bound. Yeah. That's better than the previous two ways, right? The previous two ways, we only have one-sided estimate. Here we have both side estimates. Yeah. So better than the previous two ways. Yeah. Yeah. All right. That's the formal definitions for 3 asymptotic notations. Yeah. All right. Yeah.